Built not in factories, but in backyards, these machines rise on dreams and welds. No budget, no team, just raw creativity and stubborn dedication. They challenge what's possible with each blade that spins, showing us what human willpower can truly lift. In the heart of Switzerland, a single-seat ultralight helicopter was handcrafted by an aviation enthusiast who had no team, no sponsor, and no blueprint to follow. Using aluminum alloys with key steel reinforcements, he designed each element from scratch. From the frame to the rotor head, the build relied on pure ingenuity and persistence. He wasn't chasing records. He was chasing the dream of personal flight built entirely with his own hands. Initial spin-up tests showed dangerous blade vibrations, forcing real-time redesigns. The engine, a repurposed unit, overheated constantly until the radiator was relocated for proper airflow. With each failure came learning. Carbon fiber replaced heavier sections to reduce weight, while transmission issues were solved with improvised precision. No simulator, no lab, just patience, trials, and a passion that refused to quit, even when the machine was grounded more than airborne. The creator documented everything online, every test, error, and breakthrough. It became more than a build, it became a movement. Aviation fans around the world watched as raw material slowly transformed into a flying machine. Though it never received certification or commercial attention, it turned into something arguably more powerful. A symbol of the modern aviation pioneer, built not in silence, but in full view of a global audience hungry for inspiration. And while this garage-born flyer finally hovered above Swiss soil, another builder halfway across the Mediterranean was battling the same forces of lift, torque, and gravity. But unlike the Swiss creator, he sought not just lift, but exceptional balance, without adding complexity, proving that sometimes less engineering can achieve more than expected. A self-taught engineer from Greece stunned the world by building a fully functional homemade helicopter, using only local materials and sheer dedication. Instead of chasing industry standards, he crafted each part by hand, from the steel tube frame to the fiberglass blades, proving that discipline can rival factory-grade equipment. Without outside help or major funding, he turned raw tools and garage craftsmanship into controlled, stable flight. The power plant came from an adapted automotive engine, tuned for continuous high-speed output. Every element, from the modified fuel lines to the reconfigured transmission, was optimized for one purpose: airborne endurance. The result was a rotorcraft capable of hovering with remarkable balance, even during light maneuvers. With limited tech at his disposal, this pilot engineer reached speeds near 65 knots, far above what most homemade machines achieve. Unlike typical garage projects, this machine didn't just lift, it held control in the air. The stability during forward motion was so reliable it raised eyebrows across online forums and aero circles. It wasn't just the build quality, but the foresight in balancing weight and airflow, all done with minimal computational design. Every inch of this helicopter told a story of patience and precise handwork, flying with a soul powered by ingenuity, not software. Its influence began to ripple, encouraging builders to see beyond kit manuals or factory molds. While many projects aim for distance or power, this one earned respect for refinement, showing that true performance is born from harmony, not brute force. That quiet revolution caught on elsewhere, especially in one massive country where cold winters and cold steel met in the form of another backyard pilot, ready to push his rotorcraft past the edge of what anyone expected. In the vast landscapes of Russia, a lone engineer took aviation into his own hands, literally. With no corporate backing, he built a helicopter from scratch using basic steel tubes, hand-cut rotor blades, and salvaged vehicle parts. This wasn't a high-tech lab experiment. It was a mission fueled by cold winters, grit, and a relentless pursuit of flight. His minimalist design flew not just because it could, but because it had to prove a human's will is stronger than gravity. His rotor blades were carved from layered wood, reinforced with fiberglass for strength and flexibility. The engine, a stripped-down automotive block modified to drive a single-shaft system. He tuned it to produce enough lift for slow, low-altitude flight, achieving speeds near 54 knots. The structure was brutally simple, favoring function over beauty. But when it lifted off, it silenced every critic who said backyard aviation was just a fantasy. There was no glossy paint, no flight computer, no redundancy. What he had was balance, intuition, and years of failed attempts refined into one working prototype. When it hovered, it shook. When it landed, it bounced. But it flew. This was not about elegance. It was survivalist aviation. The open cockpit exposed the pilot to wind and noise, but also gave him full sensory control over every vibration and mechanical pulse midair. What made his journey iconic wasn't just the fact that it worked. It was the proof that, even stripped of resources, humans can still achieve lift. This helicopter became folklore in underground aviation communities, not for its range or speed, but for its raw message. Anyone can fly if they're willing to build. And while this machine defined resilience across the globe, another lone builder was quietly preparing a rotorcraft surrounded by golden pastures and mountain silence. In a quiet corner of New Zealand, one man spent more than a decade shaping steel into dreams. Cameron Carter wasn't backed by labs or industry leaders, just determination. Over 12 years, he welded, bolted, and refined every piece of a homemade helicopter. His goal wasn't commercial success, it was lift. Lift born from passion, and a belief that even without a team or budget, a lone dreamer could rise from the ground under his own power. The frame, built with aluminum and reinforced steel, was designed to be simple, strong, and safe enough for solo flight. Carter chose an automotive engine, reworked to maintain steady RPMs during vertical lift. It wasn't flawless. Early versions overheated, vibrated, and resisted balance, but every setback became part of his flight manual. Through trial, error, and endless nights in the workshop, he shaped a machine that could truly leave the Earth. When it finally lifted, it wasn't a dramatic Hollywood launch. It was controlled, cautious, and careful. But the wheels left the ground, the rotors held steady, and Carter's eyes told a story no data could measure. His creation hovered with a stability few backyard aircrafts achieve. This wasn't a factory prototype. It was personal. It was a reminder that the power of creation doesn't lie in credentials, but in commitment to the long game. While Carter's machine never made it into mass production, its legacy traveled far. Enthusiasts across the globe drew inspiration from his methods and mindset. But in another corner of the world, thousands of miles away, a farmer in China was crafting something even bolder. No blueprints, no lab, just fire, steel, and a belief that rural hands could conquer the sky with the same force as the most elite engineering minds. In rural China, Xie Baogang turned heads and engines with a helicopter built from raw determination. A farmer by trade, he didn't have access to high-end composites or aeronautical engineers, just welded steel tubes, a salvaged motor, and the stubborn will to fly. What emerged wasn't just a helicopter, it was proof that cutting-edge performance could come from a backyard workshop surrounded by fields, not factories. His design reached speeds nearing 108 knots and boasted an impressive range of over 215 nautical miles. Built with aluminum-reinforced framing and custom-forged rotors, the aircraft handled sustained flight with control and stability. It wasn't a guesswork gamble, as he engineered every inch with discipline. He optimized air cooling, rebalanced weight distribution, and dialed in thrust ratios with surgical care. The cabin was basic. No advanced avionics, just the core instruments needed for short-range control. But from takeoff to landing, it did exactly what it had to: climb, hover, turn, descend. Each test flight validated years of work done in silence. While critics debated its safety, Xie's machine made believers of everyone who saw it lift and hold. It flew on raw engineering, but it soared on something greater: belief, grit, and vision forged in solitude. His success inspired not only Chinese enthusiasts, but inventors worldwide. It rewrote assumptions about where innovation can come from, and as news of his helicopter rippled through aviation circles, another craftsman, this time from a post-Soviet region, was quietly shaping his own vision of flight. Working from a modest garage, he prepared to bring human-powered ambition into the Ukrainian sky, one weld, one bolt, and one impossible dream at a time. In a small Ukrainian town, Fedir Mitryuk built more than a helicopter. He built a lesson in resilience. With no funding, little formal training, and a garage filled with scrap parts, he pieced together a flying machine that defied expectations. The dream was simple: lift off, even for a moment, using nothing more than his own ingenuity and determination. And against all odds, his creation left the ground. The aircraft featured a rugged steel tube frame, adapted vehicle parts, and handcrafted aluminum and fiber rotor blades. Its engine, pulled from an old car, was refitted to power the rotor shaft through a custom-built transmission. There were no fancy avionics or advanced materials, Just precise adjustments, long nights of measuring angles, and a commitment to solving problems with creativity instead of cash. In short flights, it proved surprisingly capable. Despite flying only at low altitudes and moderate speeds, between 40 and 54 knots, the machine held steady. Its fixed landing gear handled uneven terrain, while its compact cockpit, though crude, was functional and safe. Fedir's focus was never perfection, it was proof. And every time his helicopter hovered over the soil of his backyard, it proved that dreams take off not with wealth, but with will. While Fedir's creation hovered with the raw strength of determination, it also underscored the limits of improvised power and heavy materials. Builders worldwide watched closely, wondering how far simplification could go without sacrificing control. Across the ocean, someone was already answering that question, not with a complex frame, but with open-air design, stripped-down weight, and just enough power to defy gravity from his own backyard. Built for one pilot, the Mosquito Air was Mitch G's way of rewriting the rules of personal flight. Unlike traditional helicopters, this ultralight champion required no special facilities to operate or maintain. Crafted from high-strength aluminum tubes and a lightweight engine, it delivered vertical lift with minimal complexity. Mitch built it not just to fly, but to prove that aviation could fit inside a garage. Its engine, a two-stroke design tuned for high output, was fine-tuned for cooling and efficiency. Mitch reworked the powertrain, redesigned the intake system, and calibrated the transmission to balance weight with torque. It wasn't about pushing speed limits, but about reliable thrust and safe control. The open-frame build gave unmatched visibility, turning each flight into a panoramic experience few helicopters could rival. Flight tests revealed a calm, confident machine. It lifted off smoothly, hovered steadily, and responded well to gentle input, even in slight crosswinds. Mitch's homemade airframe, though light and bare bones, held its own in the air with poise. It became a symbol of freedom, reminding the world that, with the right knowledge and boldness, one person could create an aircraft from scratch and actually take off. The Mosquito Air wasn't just a build, it was a movement. Its success inspired a new generation of backyard aviators to take to the skies. While it soared over American fields across the Atlantic, a veteran pilot was revisiting a very different concept. He wasn't interested in ultralights, but in a legendary flying machine once featured in spy films, a machine that would go on to break dozens of records. Long before experimental flight was a trend, Ken Wallis had already etched his name into aviation history. His gyrocopters were compact, powerful, and famously featured in a James Bond film. But behind the fame was meticulous engineering. With lightweight aluminum tubing and simple mechanics, his creations weren't just props, they shattered record after record across the skies of post-war Britain. Wallis didn't chase complexity. Instead, he mastered minimalism. His rotor systems relied on auto-rotation, meaning the spinning blades generated lift from forward motion alone. No tail rotor, no fragile systems, just pure airflow physics. Powered by small but capable engines, his aircraft pushed the limits of what single-seat machines could achieve in altitude, speed, and endurance. Among his 34 recognized records were stunning feats. Fastest gyrocopter, highest altitude, longest distance. These weren't flukes. They were the result of rigorous tests and relentless refinement. Wallis believed aircraft should be accessible, dependable, and efficient. His machines embodied that ethos, turning skeptics into believers and thrilling pilots with unmatched agility and control. His work laid the foundation for what came next, not just in Europe, but globally. As engineers looked for new ways to balance power and simplicity, a quiet innovator in Japan took a bold leap. He aimed to build something most amateurs wouldn't dare, a helicopter without a tail rotor, where balance depended on two massive spinning blades rotating in perfect opposition. In a modest garage in Japan, one engineer defied convention by choosing the notoriously complex coaxial rotor system. Instead of a tail rotor, his design featured two counter-rotating blades stacked on a single axis. This setup offered stability and control in tight spaces, but required near-perfect synchronization to avoid catastrophic imbalance. For a home builder, it was a breathtakingly ambitious challenge. The structure was built with lightweight aluminum and reinforced with steel tubing in high-stress areas. The rotors were handmade from fiberglass composites, carved and layered to ensure strength without adding excessive mass. The compact fuselage remained lean and purposeful, designed around the essentials: flight stability, balance, and efficient weight distribution. Every gram mattered and nothing was added without reason. Power came from a small combustion engine, retrofitted to maintain constant output despite high torque demand. Cooling systems and fuel flow were re-engineered to support long spins at high RPMs. During test flights, the aircraft achieved short hovers and controlled shifts, movements that, while modest, proved the concept worked. It was mechanical harmony fueled by personal obsession, not corporate backing. While the machine's time in the air was brief, its impact was lasting. It proved that with deep understanding and relentless precision, even rotorcrafts once reserved for militaries could be reborn in backyard workshops. That spirit of experimentation was alive and well in Eastern Europe too, where another creator took to his yard, not with composite blades or perfect symmetry, but with steel, sweat, and the unwavering will to fly. In the heart of Hungary, Farkas Gábor set out to build something many would call impossible, a functional helicopter using little more than hand tools and garage parts. Without sponsors or teams, he worked alone, welding metal tubing and repurposing automotive components. The rotor blades, carved from reinforced aluminum, stood as symbols of trial and error, each shaped by countless iterations and raw persistence. His engine, sourced from an old vehicle, was modified to provide sustained output to the main rotor. But translating that power into stable lift was anything but simple. He wrestled with severe vibrations, unpredictable torque, and heat dissipation challenges, all while keeping his aircraft light enough to rise. After years of work, the machine finally took off, just inches off the ground, but enough to prove it could fly. Each short flight was more than a mechanical test. It was a deeply personal achievement. With every adjustment, Gábor refined control and improved the machine's response, proving that ambition, not infrastructure, defines what can take to the skies. He had no wind tunnel or advanced telemetry, only intuition, trial, and relentless refinement. And yet, what he built flew. That was enough. Gábor's journey reflects the rawest essence of experimental aviation. No blueprint, no shortcuts, just passion forged into steel and lifted by the will to rise. His machine was imperfect, but entirely his own, a working aircraft born from imagination, not industry. It reminded the world that even in the quiet corners of rural Europe, the sky still answers those bold enough to ask. What if the sky wasn't reserved for experts? These flying machines remind us that innovation doesn't ask for permission, it just takes off. Inspired? Drop your thoughts in the comments. Crave more real-life breakthroughs? Hit the like button. Got friends who dream big? Share this with them. And if you love stories where limits are broken, don't forget to subscribe. Watch the videos that appear here on the screen and stay with us. Bye-bye.